Did you know that there are 90 different species of whales roaming our oceans? They're the largest animals ever to have existed on Earth. These massive creatures have been around for nearly 50 million years and continue to captivate human imagination. But how did these giants of the sea evolve? And what fascinating adaptations allow them to thrive in such diverse marine environments? In Wild Lineage, we will dive deep into the evolutionary lineage of whales, exploring their ancient ancestors and the remarkable changes that have shaped them over millions of years. Welcome to Wild Lineage, Episode 2. Our topic today is whales. Nearly 56 to 50 million years ago, during the early Eocene epoch, in the lush jungles and river systems of what is now Pakistan, there lived an animal named Pakicetus. This ancient creature is considered one of the earliest known ancestors of modern whales. It is believed to have spent time both on land and in water, showcasing the transitional nature of early cetaceans. Pakicetus was relatively small, measuring about 2 to 3 meters or 6.5 to 10 feet in length. Its body structure resembled that of a large wolf or dog, with elongated limbs and a long, narrow skull. One of its most distinctive features was its unique ear structure, which indicates it had adapted for hearing underwater, a crucial trait for life in aquatic environments. Unlike modern whales, Pakicetus had a set of sharp, conical teeth that were ideal for catching fish and small prey. This reflects its early carnivorous diet as it transitioned from terrestrial to aquatic life. However, Pakicetus eventually went extinct around 50 million years ago, likely due to changes in climate and habitat as the Earth transitioned into the later Eocene, which led to the rise of more specialized cetaceans. Pakicetus represents a pivotal moment in the evolutionary lineage of whales, highlighting the adaptations that began the journey toward fully aquatic living. Its fossils provide crucial insights into the transformation of land-dwelling mammals into the magnificent marine creatures we see today. Nearly 50 million years ago, during the early to middle Eocene epoch, in the shallow coastal waters and estuaries of what is now Pakistan, there lived an animal named Ambulocetus. Often referred to as the walking whale, this creature displayed unique adaptations that allowed it to thrive both on land and in water, marking a significant step in the evolutionary lineage of modern whales. Ambulocetus was relatively large, measuring about 3 to 4.5 meters or 10 to 15 feet in length. Its body was elongated and streamlined, resembling that of a modern otter. It had strong, muscular limbs capable of supporting its weight on land. Its skull was long and narrow, featuring conical teeth well suited for catching fish and other aquatic prey. One of the most notable characteristics of Ambulocetus was its remarkable combination of features. Its limbs were adapted for both swimming and walking, suggesting it could move through water with agility while also venturing onto land. This adaptability made it a formidable predator during its time. Ambulocetus played a crucial role in the transition of cetaceans from land to water. However, it went extinct around 48 million years ago, likely due to competition with more advanced marine mammals and changing environmental conditions that favored fully aquatic adaptations. Nearly 48 to 40 million years ago, during the Middle Eocene epoch, in the warm coastal waters of what is now Pakistan, there lived an animal named Rodhocetus. This ancient creature serves as a crucial link in the evolutionary lineage of modern whales, showcasing advanced adaptations for a fully aquatic lifestyle. Rodhocetus was a sizable cetacean, measuring about 4 to 5 meters or 13 to 16 feet in length. Its body was more streamlined than its predecessors, with a fusiform shape that minimized drag in the water. It had strong, paddle-like limbs, signaling a significant shift towards swimming efficiency. However, the limb bones retained some features indicating that it might still have been able to move on land, albeit less effectively. A distinctive feature of Rodhocetus was its elongated snout and conical teeth, which were ideal for grasping slippery prey such as fish and squid. Additionally, its skull exhibited adaptations for enhanced underwater hearing, an essential trait for communication and navigation in its marine habitat. Rodhocetus represents a pivotal evolutionary step toward more specialized aquatic forms. However, it went extinct around 40 million years ago, likely due to environmental changes and increasing competition with more advanced cetaceans emerging during this era. Nearly 40 to 34 million years ago, during the late Eocene epoch, in the warm, shallow seas that once covered parts of North America and North Africa, there lived a remarkable creature named Basilosaurus. This ancient whale represented represents a pivotal stage in the evolutionary history of cetaceans, exhibiting adaptations that allowed it to dominate as a fully aquatic predator. Basilosaurus was an impressive marine mammal, measuring about 15 to 18 meters or 50 to 60 feet in length, making it one of the largest animals of its time. Its elongated, serpentine body was perfectly streamlined for efficient swimming, with a powerful tail propelling it through the water. Its reduced, flipper-like forelimbs indicated a complete departure from terrestrial movement, showcasing its commitment to an aquatic lifestyle. A defining feature of Basilosaurus was its elongated skull, housing sharp conical teeth ideal for capturing a variety of prey, including fish and large cephalopods. Interestingly, it still retained small vestigial hind limbs, a reminder of its terrestrial ancestry, although these limbs were no longer functional for movement. Basilosaurus represents a critical milestone in whale evolution, marking the shift from semi-aquatic ancestors to fully marine forms. This fascinating species thrived for millions of years, but eventually went extinct around 34 million years ago. Its disappearance was likely influenced by changes in ocean temperatures, prey availability, and competition with more advanced marine mammals that were emerging during this period. Nearly 40 to 34 million years ago, during the late Eocene epoch, in the warm, shallow seas that spanned parts of North America, Europe, and North Africa, there lived an ancient whale known as Dorudon. This remarkable creature represents a key chapter in the evolutionary lineage of modern whales, showcasing adaptations that solidified its place as a fully aquatic mammal. Dorudon was relatively large, measuring about 4.5 to 5.5 meters or 15 to 18 feet in length. Its streamlined body was perfectly suited for life in the water, with powerful flippers and a strong tail that allowed it to navigate its marine environment with agility. Unlike its larger predecessor, Basilosaurus, Dorudon displayed a more compact and specialized form optimized for efficient swimming. The skull of Dorudon was elongated and featured sharp conical teeth, ideal for catching slippery prey such as fish and squid. It also had advanced adaptations for underwater hearing, suggesting it may have developed early forms of communication or echolocation, crucial for survival in the darker depths of the ocean. Dorudon stands as an important evolutionary milestone, bridging the gap between earlier cetaceans and the modern whales we know today. This fascinating species thrived in marine environments for millions of years, but ultimately went extinct around 34 million years ago. Its demise was likely driven by environmental shifts and increasing competition with other emerging marine mammals during this transformative period. Nearly 34 to 15 million years ago, during the Oligocene to Miocene epochs, in the diverse marine environments of the North Atlantic and the Southern Hemisphere, there lived an ancient whale known as Cetotherium. This remarkable creature played a crucial role in the evolutionary history of baleen whales, showcasing adaptations that reflect a more specialized feeding strategy. Cetotherium was a relatively large whale, measuring about 15 to 20 meters or 49 to 66 feet in length. Its streamlined body resembled that of modern baleen whales, enabling it to glide efficiently through the water. One of its most notable features was its baleen plates, which had evolved for filter feeding, allowing it to consume vast amounts of small prey such as krill and plankton. The skull of Cetotherium exhibited adaptations for filter feeding, including a broad, flat rostrum and elongated baleen plates, both of which facilitated its unique feeding method. Unlike its ancestors, which had teeth, Cetotherium relied on its baleen to strain food from the water, marking a significant shift in feeding strategy among cetaceans. As the whale lineage evolved, it split into two major groups: the baleen whales, like Cetotherium, which filter feed on small organisms, and the toothed whales, which hunt larger prey. Among the toothed whales, species like Livyatan represent formidable predators that highlight the adaptations of this group. Cetotherium represents a pivotal evolutionary step in the lineage of baleen whales, illustrating the transition from toothed ancestors to the filter-feeding giants we see today. This fascinating species thrived in various marine environments, but eventually went extinct around 15 million years ago, likely due to changes in climate and oceanic conditions that impacted prey availability. Livyatan lived around 12 to 8 million years ago, during the Miocene epoch, in the deep waters of the oceans. This ancient toothed whale is renowned for its impressive size and unique adaptations, making it one of the top predators of its time. Measuring up to 17.5 meters or 57 feet in length, Livyatan was a massive creature, rivaling the size of modern sperm whales. Its robust body was built for powerful swimming, and it possessed a large, elongated skull with massive teeth that could grow up to 36 centimeters or 14 inches long. These adaptations allowed Livyatan to hunt large prey, including other marine mammals. Livyatan's most remarkable feature was its teeth, which were conical and robust, perfect for gripping and tearing into flesh. This distinctive dental arrangement suggests that Livyatan preyed upon large marine animals, including Carcharical's megalodon, the giant prehistoric shark. The presence of both Livyatan and megalodon in the same waters created a perilous environment. As apex predators, they would have competed for food resources, possibly engaging in fierce battles for survival. The sheer size and predatory nature of Livyatan, combined with its powerful jaws and formidable teeth, made it a fearsome hunter capable of taking down even the largest sharks of its time. Fossil evidence, including tooth marks found on megalodon remains, suggests that Livyatan may have been involved in direct predation, highlighting the dangerous dynamics of the ancient marine ecosystem. Imagine the chaos of these titanic creatures clashing in the depths, each vying for dominance, a true battle of the giants beneath the waves. Despite its success as a predator, Livyatan eventually went extinct around 8 million years ago, possibly due to changes in ocean conditions and competition for food sources. Blue whale has lived from around 4.5 million years ago to the present, with its origins tracing back to the late Miocene epoch. As the largest animal known to have ever existed on Earth, the blue whale can be found in oceans around the world, from the frigid Arctic to the warm waters of the equator. Reaching lengths of up to 30 meters or 98 feet and weighing as much as 200 tons or 181 metric tons, blue whales are truly massive creatures. Their long, streamlined bodies are adapted for efficient swimming, with powerful flippers and a large, flat tail fluke that helps propel them through the water. Their bluish-gray coloration, often mottled with lighter spots, allows them to blend into their oceanic environment. One of the most remarkable features of the blue whale is its baleen plates, which hang from the upper jaw and are used to filter feed on small shrimp-like animals called krill. During feeding season, a blue whale can consume up to 4 tons or 3,600 kilograms of krill each day, showcasing its incredible ability to thrive in marine ecosystems that offer abundant food sources. As the largest animal in history, the blue whale represents a pinnacle of evolutionary adaptation, showcasing how life in the ocean has transformed over millions of years. Unlike its ancient ancestors, blue whales have evolved specialized feeding strategies that enable them to sustain their massive size in a world where competition for food is fierce. Despite their size and adaptations, blue whales face threats from human activities such as ship strikes and entanglement in fishing gear, as well as the impacts of climate change on their food sources. Conservation efforts are underway to protect these magnificent creatures and ensure their survival for future generations. So that's it. With this, we've completed our journey through time, exploring the evolutionary lineage of whales. From the land-walking Pakicetus to the ocean giants like the blue whale, they've undergone some of the most remarkable transformations in Earth's history. Moving from land to water, adapting to new ways of feeding, it's truly impressive to think about how much they've changed over millions of years. This is the lineage of whales. You're watching Wild Lineage, Episode 2. See you in the next one.